Algebraic solution of linear inequalities. First, consider one example. I am taking one equation first. Equation is x plus 5 equals to 0. When we put x equals to minus 5, we'll get 0 equals to 0. It means x equals to minus 5 is the solution of the given equation. Now consider this inequality. 2x is less than 9. When we put x equals to 0, we'll get 0 less than 9, which is true. For x equals to 1, 2 less than 9, which is also true. For x equals to 2, for x equals to 3, for x equals to 4, this inequality is true. Now for x equals to 5, we'll get 10 less than 9, which is false. So in the above situation, we find that the value of x, which makes the above inequality a true statements, are 0, 1, 2, 3, 4. These values of x, which make above inequality a true statement, is called solutions of inequality, and the set of all the values is called solution set. Thus, any solution of an inequality in one variable is a value of the variable which makes it a true statement. We have found the solutions of the above inequality by trial and error method, which is not very efficient. Obviously, this method is time consuming and sometimes not feasible. We must have some better or systematic technique for solving linear inequalities. Before that, we should go through some more properties of numerical inequalities and follow them as rules while solving the linear inequalities. Now you recall that while solving the linear equations, we followed the following rules. Rule number 1 is equal numbers may be added to or subtracted from both sides of an equation. Suppose an equation is given 3x plus 5 equals to 10. We can add equal number or we can subtract equal number to the both sides of the equation. In that case, the equation remains same, means there will be no change in the equation. Suppose if we add 2 to the both sides of the equation, or if we subtract 8 from the both sides of the equation, in both the cases the equation remains same, means there will be no change in the equation. Second rule is both sides of an equation may be multiplied or divided by the same non-zero number. We can also multiply or divide by the same non-zero number to the both sides of the equation. In the case of inequality, in the case of solving inequalities, we again follow the same rules. Rule number 1, equal number may be added to or subtracted from both sides of an inequality without affecting the sign of inequality. For example, one inequality is given 2x less than 11. We can add, or I'm taking numbers only, 2 is less than 11. If we add 5 to the both sides of equation, then 2 plus 5 is less than 11 plus 5. So we'll get 7 less than 16, which is true. See, there is no change in the sign of inequality. We can also subtract same number to the both sides of the given inequality. For example, 4 is less than 7. If we subtract 7 or 8 to the both sides of the inequality, then we'll get minus 4 is less than minus 1. Minus 1 is greater than minus 4, or minus 4 is less than minus 1, which is also true. So first rule is we can add or subtract same number to the both side of an inequality. Second rule is both sides of an inequality can be multiplied or divided by the same positive number. But when multiplied or divided by a negative number, then the sign of inequality is reversed. For example, 3 is greater than 2. If we multiply both sides by positive number, let it be multiplied by 2, then we'll get 6 is greater than 4, which is true. Or if we divide by a positive number, in that case also there will be no change in the inequality, in the sign of inequality. But if we multiply or divide by a negative number, I am taking the same example. If we multiplied both sides by -4, then we'll get -12 and here -8. Now we cannot put this sign greater than, because this -12 is not greater than -8. This is less than. Now see, when we multiply by a positive number, then there will be no change in the sign of the inequality. But when we multiply by a negative number, then the sign of inequality is reversed. We'll use both the rules for solving an inequality.